here we begin debugging a count substring case. And again, we have a function, count substring, that takes 4 parameters. It takes 2 strings, the string itself and the length, for both the string to be searched and the string to be searched for. And it counts how many instances of that string, of the second string, exist in the first string. And in the MIPS code, we see that there is a call to this, and we're passing in the parameters string and its length, and string is this SSA, SA, so on and so forth string, and substring is the string SA and its length is 2. And so from running this code, we'd expect to find 5 copies of SA in this first string. There's the first one, there's the second one, there's the third one, there's the fourth one, and there's the fifth one. So we'd expect to see the value 5 printed, but on running this code, what we instead see is the value 0. So we're pretty sure that there's a bug in our code somewhere, and to go and find it, again, we're going to step through our code to look for that error. So again, I'm going to step over the main function until I get to the point of this count substring. So what I can do is I can start looking at the code at the execution of the count substring. And so I could set a breakpoint at this instruction, which is calling count substring. So I can set a breakpoint at address, the one listed here, which is hex 400054. So I can add that breakpoint, and then I can run the code up to that point. So it ran up to hex 400054, and I'm going to abort that command now because at this point I want to step through the code. But the nice thing about doing it this way is that I didn't actually have to step through all of the code before that. I could run through that full speed to the point that I was interested. But now I'm here, I'm going to step, and that's going to get me into the code associated with count substring, and I'm going to go ahead and walk through this code. So the beginning of this code is pretty straightforward. I'm just setting up some values that indicate, these are some constants. So I'm initializing, well, not constants, but initializing variables. I'm initializing count to 0, I to 0, and how many potential places substring could start in string by subtracting the lengths of those two things. So I step through those, and that seems to generate reasonable values. Generates the value, initializes it to 0, 0, and D, which f minus 2 is D, so those look pretty good. I'm going to start the code in earnest, and so for this code, I'm going to look, the first thing is this branch greater than equal. So basically I expect this loop, this outer loop, should execute D times. And so the first iteration I expect should fall through. And so we can go ahead and step. So that BGE is broken into 2 instructions, the SLT and the BEQ. And I can see that we did in fact step into the loop. So we didn't have some early exit. That was unexpected. And then we're going to initialize 2 more variables. So that's what these 2 OR immediates are. And again, we're going to now do the inner loop, which says, okay, at each position in the code, we're going to see if we have a matching string. And so again, we would expect that we haven't reached the end of this inner loop, so we expect this branch to fall through, and in fact it does, so that gives us the expected behavior at least on the first iteration. And then what we're going to do is we're going to load the two characters, one from the first string and one from the second string, and compare them. And so if we look at the two pieces of code, the first letter of the first string and the first letter of the second string are both S's, so we expect that this comparison should succeed. And so we'll go ahead and step through this code. The first one loaded into register T4, and it loaded the value 73, which we've come to know is for the letter S. And the second one loaded into register T4 the value 73. And so I'm a little wary of this already, but we can see that we'd expect these two S's to compare, and what you can see, if they do match from the C code, this comparison shouldn't be true, in which case we'll go around and we'll do another iteration of the loop. But what we see, the way the code's been translated, is we have a branch if equal that would skip over these two things, which is the match equals false and the break. But what happened is we actually fell through into those pieces of code that we're setting match equal to false, which is T2. So T2 was 1, and after I execute this instruction, it's now 0, and we have the break. So that's not the expected behavior, and we kind of saw this coming because T4, and it was comparing T4 and T5. So this branch in the code is comparing T4 and T5. And if we look at T4 and T5, those values obviously don't match, even though they both should be ASCII S's. And that problem comes back to the fact that I loaded T5, or I took the address that was in T5 and loaded it into T4. And so what this code is actually expecting me to do is load that into T5. And so if I fix up that error, I can reload the code, and this time I'm just going to run it to completion, see if it works, and in fact it does work, suggesting to me that that's the only error, at least it's the only error that was exposed by this test case. So we can quickly step through the code again to the same point, that if I want to check exactly at that point whether it's doing the right thing, again I can set a breakpoint there. So here's my 2 load bytes, and I'm expecting now at this branch if equal for it to for those two things to be equal, and so the branch will be taken. And so I can set a breakpoint at that point, and I can skip directly there. I can run. So now I'm at that branch if equal, and if I step at this point, it should jump over those conditions, which in fact you could see it did. So this is where my branch was. It jumped over these two instructions, and now I'm there. So that's why the code is actually working correctly.